Hello academics, welcome to the fourth video of this series, and today we're going to be learning how to get an equation for a function based off a graph. And so to do this, we're going to be using the zeros. So this is just a simple way of saying the x-axis intercepts. And so that means, let's say we're looking at a function here. We're going to be getting an equation for this function based off where it intersects with the x-axis, right? And so to do this, we're going to use a simple principle. And it's that this function, whatever it may be, we know that f of x will be equal to 0 at points x equals, and what these are here, right? Because this function represents the flowing change of f of x. And so we know it'll be 0 at these x's. So if we can find what these x's are, we can get one step closer to getting this equation. And so to do that, we're going to start off with an example that we're going to work through together. So let's first take a look at this. We can see that it has 3 x's because it has one here, and one there. So our x1 will be equal to -2. Our x2 will be equal to 0. And our x3 will, oh, sorry, not right there. It's right there. Our x3 is equal to, that is 4. So let's just write this down. Our first step is find the x's. And so x1 equals -2, x2 is equal to 0, and x3 is equal to 4. I always recommend that people write these down because often some people forget about some of them because they try to do it too quickly on an exam or a test, and that's when it leads to errors and confusion. So it's best to just get it right the first time and take your time the first time. And so from there, we're going to establish a principle here, right? We're going to use f of x is equal to some constant. This is a sizing constant. Don't worry too much about it now. I'll explain a little more in a second. But times, and then here's where it gets a little tricky, because we want to make sure it's equal to 0 when x is equal to -2. So I'm going to put x plus 2, because once I put this -2 in it, it'll become 0. If that's not clear so far, just follow along and I'm explain a bit more. But here I'm going to put x, and then I'm going to put plus 0, because when x is 0, I will still want it to be 0. And then times finally x, and I'll put -4. So if you haven't caught on already, let's say I substitute x equals -2 into it. So let's put a equals, and then I'll sub in -2 plus 2, and then here I'll put, oops, sorry, I'm getting all over the place, and then here I'll put -2 plus 0, and then times, and then I'll put -2 minus 4. So this is equal to a times 0 times -2 times -6. And because of the 0 here, it's all equal to 0. And so we know it works for the first one. So let's keep moving along. Let's try it out for the second one now. And so we're going to put a, and then we're going to put x equals 0, because that's the second 0 we got there. So we're going to put 0 plus 2 times 0 plus 0 times 0 minus 4. And so there we get a times 2 times 0 times -4. And so again, because of this little 0 there, it's all equal to 0. So it works again. And so now for the last one, we have, and we're going to use, we're just going to use 4. So this is x, or 4 plus 2 times 4 plus 0 times 4 minus 4. We get a times 6 times 4 times 0. And again, it's equal to 0, which is what we want f of x to be equal to at this point here. And so we can see that this solution works. And we'll go, and you might be wondering, what is the a? And so that's what we'll go into depth now. And so to do that, I'll get rid of this. And I'll show that I can make another function that has these exact same zeros, but that isn't f of x. Right, so I'll come in here, I'll go up, I'll cross there, come down, cross there, and then up like that. Oh, missed it just a bit there, but you guys get the point. Just like that. We can see this is a different function. But if it was, I would have came to the same conclusion for the x's. And so that's why we have this scaling a, because this a is what determines, we can say, how aggressive the function is, how quickly it turns, and how aggressively it goes down and up. And we can see here it has a higher leading coefficient because of it. But if that doesn't make too much sense, in a later lesson we're going to go through transformations, and you'll be able to see that a little more clearly. But for now, it's good to have just a base knowledge. And the final thing we're going to look at is a way to test if the function equation that we've come up with could be a solution. And so to do that, we're going to see that this function has 1, 2, and 3 intercepts. And so, we can look at the maximum. So it has 1 maximum and 2 maximum. And so that means from our equation, we know that the degree minus 1 is equal to the number of mins slash maxes. And so the degree of this should be 2 and then plus 1, because we send that to the other side, which is equal to 3. So the degree should be 3. And if we look here, we're going to have 1x, 2x, 3x. So once we multiply this all out, it's going to be equal to a times x cubed plus and all the other numbers. But all we care about is checking to make sure that the degree here is the same. And so we can see that because the degree is the same, it should work. And just keep in mind, this is an introductory lesson, and so it gets a little more complicated, and this rule won't always work, but it will work when you're just doing a simple polynomial, when there's no additional factors that we'll get into later in the course. But for now, this is a simple way to check during your homework, but don't necessarily do this on a test because it will not give you all the points. But if that works, then we'll move on to the second lesson, or the second example. So for this example, I'll give you guys a second to do it first. If you guys don't get it, that's fine. I'm going to give the solution in just a moment, but feel free to pause it and try it to get the solution. Okay, so assuming you guys have all given it a try now, we're going to do this little lesson here, this little example. So we're going to identify our x's, because that's always our first step. Find x's. And so our first one here is x equals -5. Here we have x equals -2, x equals 1, and x equals 4. So those are the 4 that we have found. And so what we're going to do is we're going to write f of x is equal to a times, and then we'll put x plus 5, because remember we want to invert the sign so it's equal to 0 once we put the x in, times x plus 2 times x minus 1 times x plus 4. Just like that. And so this is the solution to this problem. Again, we can check it by looking at the degree that it could be. And so that's 3 plus 1. And so the degree should be equal to 4. And if we look, we have 1x, 2x, 3x, 4. So once we multiply this all out, it'll be equal to x to the power of 4 plus a bunch of other numbers there. But, so that's it for this lesson today. If you have any questions at all, feel free to leave them down in the comments, and I'll be happy to answer you guys. But if not, I wish you guys have a great day, and thank you for watching.